Hello everyone, my name is Laura Valentina Garzón Guiza and I'm currently studying for a master's degree in Systems and Computer Engineering at Universidad Nacional de Colombia, and today I'll present the concept trunk-based development for the subject Advanced Topics of Software Engineering. For this presentation, I'll give a short introduction about the concept of trunk-based development. Then I'll talk about the key rules with this technique and how it should look with a short example. After that, I'll give the description of some other key points and concepts important for the understanding of this topic. Trunk-based development could be understood as the more straightforward workflow, as we have only one branch line, which makes it easy to understand. Trunk-based development refers to the working technique in which all changes are checked into the main branch, which is commonly the main branch or master branch. So to stay within the mostly known nomenclature of Git flow or master-based development, trunk could be replaced with master to be more familiar with the term. The basic rules of this technique are really simple. First, everyone pushes to the master branch. This is like the key rule of this workflow. And also, no long-term branches next to the master, so we don't have a development branch like in Gitflow or any kind of other branch or like feature branch that should really be going parallel with our master branch. Feature branches are not desirable with this technique, but if developers use feature branches, there is also like two rules. These rules are not written down like a must in this technique, but it's just how this workflow was designed for, and it basically just says that just one developer per branch, and the branch should not be living longer than 2 days. The feature branches actually that you would use in this workflow would really differ from the feature branches for teams because primarily in their scope, in the trunk-based development, the tasks must be very small since only one employee is allowed to work on the problem and has only like up to 2 days to do so. In addition, feature branches are actually optional in trunk-based development because in the best case, all team members push directly to the master branch. So let's have a look at an example. That's kind of how it would look like. Just one branch, and in this case, I had like 4 or 5 developers, and they just pushed their changes to the master branch. Now let's talk about the key points that should be taken into account. A requirement for successful work with this technique is that it is functioning with continuous integration pipeline because that pipeline will ensure the quality of the software with sufficient tests, which include unitary test, API test, end-to-end test, load testing, and many others. Now, if there are problems in the code, the pipeline will sound an alarm and a developer will trigger the error that is required to be fixed as quickly as possible, because as long as the pipeline is broken, no commit from other team members will make it into the finished software. It is common for a team to establish a certain culture where no one really likes to break that pipeline because as a result, commits are well tested before developers push their code to the server, which kind of benefits the quality of the overall software. Ideally, however, developers can test their code locally before they push their changes to the server because this will greatly reduce the risk of a broken pipeline. So one of the advantages of trunk-based development is that the latest state of the development is always release ready, or it actually should always be release ready, because that's the main argument of this workflow. So for example, let's presume that management decides that the actual project, which has existed in the master branch for a few days, just tested by the QA team, needs to be rolled out today. In the best case, the project manager reassures the development team that everything is going according to plan and brings the latest build, which may be only a few minutes old, to the production environment. This confidence in those stable builds develops from a reliable CI/CD pipeline. The pipeline constantly evolves over the life of the project and becomes more reliable with each bug fixed and each new test. Because if you have ever worked in a trunk-based development, you will see how much testing there is actually being done. It's actually really different from any other workflow in this aspect. And if you've gained a lot of confidence in your CI/CD pipeline and want to satisfy your customer as quickly as possible, you can even automate the process of rolling out the software. One common question is how are complex features to be developed that can't be finished or put into production in one day or two because you can't build every possible feature just in a couple of hours or days. So one way to deal with this problem is to use feature flags or feature targets. Feature flags involves most of the time building queries into the code that decide whether certain functions are available or not. In a simple case, you can think of this as an if query in the software, but a condition does not have to be simply version dependent. Obviously, you could also enable certain functions for certain user groups. For example, functions can be tested by the QA team in production before other users having access to this function. To make the function visible to all users, you don't need to install the new version. But in the best case, you would just, modify a database entry or just change a variable, depending how you solve this issue in the first place to either show or hide a certain functionality in your application. Now, as a summary, let's talk about the advantages and disadvantages of using trunk-based development or TBD. The benefits of trunk-based development are that the source code is always release ready, or at least it should be always release ready. Otherwise, this workflow doesn't make much sense. Obviously, another benefit of it is that you don't really merge anything really big or complicated. You may have some feature branches here and there, but they are so short with the small commits. Another one is a smaller conflicts. This is probably kind of simple because if you just make some changes and push instantly to the master branch, you will not have a feature or a change that has been going on for weeks or several days that might suddenly cost you a big merge conflict. And the best or basically the worst case is just a couple of lines that you might need to check or fix, but the conflicts should always kind of remain small. Another one is that clean code is a must, but done for the reason that the developers kind of have a pressure because whatever they push to the server should not make the pipeline fails. Because as previously mentioned, if the pipeline fails the build and the code is not fixed, the pipeline will not work and no one else can push their changes to the server because the pipeline build just failed. So there is a certain pressure on developers in this trunk-based development. Also, TBD ensures that all changes committed to the main branch are always in a working state, as every change immediately integrated and tested. This helps to avoid integration hell, during which various changes conflict with each other and cause the main branch to break. The frequent small commits made in TBD make it easier to find and fix bugs, and there is less code to search through, and changes can be traced back more easily, and also make it easier to review code changes, as there is less new code to review in each commit. Um, the close collaboration required by TBD can help to improve communication among team members and build a stronger team spirit. For this case, often pair programming is used to enhance TBD. In addition, TBD can help to get feedback faster on your change. It reduces the risk of project failure as any issues are found and fixed more quickly. And finally, TBD can lead to faster delivery of new features and improvements as there is no need to wait for lengthy integration and testing phases. Instead, changes can be released as soon as they are ready. Well, now let's talk about the disadvantages. It could be difficult to start for inexperienced developers. Why? In other workflows, if you have a new developer or someone who is not experienced, he or she can usually work on his own branch and will then basically create a pull request or a merge request to merge his changes into the develop or master branch. And then some other developers can obviously have a look at it and say, hey, please, change this, or this could be better done, or comments like that. But in trunk-based development, inexperienced users don't really
have that possibility because creating feature branches is still not a wise. To be precise, if we use TBD as it was strictly defined, one of the characteristics of this technique is no feature branches and no pull requests as there are no branches to merge. But how do we make sure that nobody messes things up without pull request? There is a great tool that helps to solve this problem and is pair programming. Pair programming is a method of programming where two or more developers work together at the same time on the same code. This can be done in person or over a video call. Pair programming can also help improve communication between developers because by working together, two developers can share knowledge and ideas, and each can help keep the other accountable for following best practices. In addition, pair programming can help reduce the number of potential bugs in a code base, and this can lead to improved code quality. Pair programming helps to ensure that all code changes are reviewed. Before they are committed to the main branch. The review goes along with actual coding. Usually, one developer does the actual coding and the other one does a real time review and helps with ideas. The code has better quality because there are two pair of eyes looking at it and it does not need any additional review then. That's why it is often used in conjunction with TBD. Um, Coming back to disadvantages, another thing that you probably can imagine is that it can get really messy in a big team. For big projects with really big teams, newcomers could mess up things, maybe committing something wrong because they didn't know they shouldn't, or the documentation was not complete or wasn't clear. So companies that have a large amount of developers and use trunk-based development have extra programs or applications to do a really extensive testing to make this work. But in an ordinary company, it might not have the financial stability to get all those kinds of applications that you could use together with trunk-based development in order to really make this technique work. So one such disadvantage is the potential for increased conflicts when a big team of developers are working on the same code base. This is because each developer will have their own local copy of the code and changes made by one developer may not immediately reflected in the other developer's code base, which can lead to merge conflicts when developers attempt to push their changes back to the central repository. Also for projects with a huge number of classes and functionalities, when the developers don't know the application well, they could delete important code. In large organizations with hundreds or thousands of developers, it's difficult to implement this technique, TBD. This is because each developer would need to have their own local copy of the code, which would require a lot of storage space. Additionally, it would be difficult to manage and keep track of all different code bases. And finally, trunk-based development can also make it difficult to roll back changes. This is because each change is made directly into the trunk and there is no separate branch for holding previous version of the code. If a change needs to be rolled back, it can be difficult to identify which change caused the problem and how to revert it. From the book Accelerate, written by Nicole Forsgren, Jess Humble, Jen Kim, they conclude from their research that developing of trunk master rather than on long-lived feature branches was correlated with higher delivery performance. Teams that did well had fewer than three active branches at any time. Their branches had very short lifetimes, less than a day, before being merged into trunk and never had code freeze or stabilization periods. They remarked that these results are independent of team size, organization size, or industry. Even after finding that trunk-based development practices contribute to better software delivery performance, some developers who are used to GitHub Flow workflow remain skeptical. This workflow relies heavily on developing with branches and only periodically merging to trunk. They have heard, for example, that branching strategies are effective if development teams don't maintain branches for too long, and they agree that working on short-lived branches that are merged into trunk at least daily is consistent with commonly accepted continuous integration practices. They conducted additional research and found that teams using branches that leave a short amount of time, integration times less than a day, combined with short merging and integration periods less than a day, do better in terms of software delivery performance than teams using longer lived branches. Based on their experience, they hypothesize that this is because having multiple long lived branches discourages both refactoring and intra-team communication. But they also note that GitHub Flow is suitable for open source projects whose contributors are not working on a project full time. In that situation, it makes sense for branches that part-time contributors are working on to live for longer periods of time without being merged. So thanks for your attention, and if you have any question, you can mail me at the email below.